The M4 carbine that Special Forces units had in 1996 was a piece of junk compared to the versions soldiers carry today. The change had to happen because it all started when the Army wrote a stupid accuracy requirement for the M4A1 that no production carbine barrel firing ball ammo could physically meet. But somehow they rushed and sent the gun to production anyway. So what they wanted back in 1994 was to have the rifle shoot a 4x3 0.4-inch group at 600 yards using the standard M855 ammo. If you don't know what this means, it was pretty much asking the M4 to hit sub 1 MOA accuracy from a 14.5-inch barrel like a DMR and expecting that from an enlisted rifleman. Even with a precision bolt-action rifle, which it was already hard enough back then, and at best with the M855 out of a match-grade barrel, was roughly just 2 MOA. So if you compare a standard production barrel, the best soldiers got was roughly around 12 to 18 inches of vertical spread at that distance. So long story short, the military approved it and moved on with it, which exposed a bunch of other problems. So the M4A1's original barrel ruptured under full auto fire, and the Army's own 1996 study documented it happening between 540 and 596 rounds when fired back to back. For example, the barrel warped when it gets overheated, and they only shot through 3 consecutive mags on full auto. If you just do the math, that's only 90 rounds, and at this rate, no one in the field can achieve fire suppression if they needed to, and that prompted more testing. And later the test data was sitting in a report showing that the M4's barrel and its own fire control system were fundamentally mismatched from day one. So they went to the Navy's Crane Research Center for some answers, and the fix they ultimately came up with was to use a heavier barrel profile. How it works was that they wanted the barrel to survive at least 800 rounds of sustained full auto before failing. The additional mass on the barrel can absorb heat before the barrel wall starts losing structural integrity. And Crane came back with a test confirmation that 800 rounds was the specific threshold they were working toward. If you think about how many bullets are fired during extended gunfights, eventually they will get hot too, and they will exceed the 800-round threshold if there weren't other support weapons stepping in to help. So the SOCOM heavy barrel solved the problem it was built for, but when you change one part of the gun, the rest of the gun needs fix, and a bunch of problems started showing up. For example, the chrome lining inside the barrel was too thick to extract shells under heat. So the chrome lining inside those chambers had been applied slightly too thick, or the chamber itself cut slightly too narrow. As chamber temperature climbs during firing, the tight dimensions grip the brass case harder than the extractor can overcome, and the spent casing expands and has a harder time to eject. The critical nuance is that these guns all passed inspection on a cold bench because the defect was invisible until the weapon reached operating temperature. The quality control process was approving guns with a built-in failure mode that only revealed itself once a soldier started shooting. And this was basically saying that the Army had no idea how many carbines across the battalion had the same problem. The next big issue was the extractor spring. So when they went back to Crane regarding the ejection issue, and the response was to change the extractor spring from a 4-coil to a 5-coil design with a longer insert and added the Crane O-ring. If you look at this image on the left was the old one, and the one on the right has that small rubber ring wrapped around the extractor body. Basically, it's there to increase the mechanical force applied to every spent case. The combination made the extractor grab onto the casing lip tighter for ejection, even if it gets super hot. However, the fix only addressed the symptom rather than correcting the root manufacturing tolerance problem. But it worked for the time being. And there was a report stating that it converted a 15% failure rate into something soldiers can confide in. During this time, the Iraq invasion was building up, and Army armorers were rebuilding these extractors that were going into Iraq within weeks. So there wasn't enough time to verify the fix under anything close to actual combat conditions. Every M4A1 that entered Iraq during the initial invasion was running a component that had been changed specifically because a manufacturing defect in an entire group's worth of new guns got caught at the last moment before going into combat. The fix fortunately worked, and that lesson learned was something the Army took into future weapon development. But that wasn't the only problem. The next problem was the overpressuring in the gas system. Remember, this was so long ago, back during a time where not many people understood the gas system like we do now. So the M4A1's carbine length gas system was running the bolt carrier group harder than the design needed from day one. And at least the Army understood the physics well enough to acknowledge the problem. But they didn't act on it for nearly 2 decades. So, the basics is this, if you're unfamiliar. On a 14.5-inch barrel, carbine length gas cycles the action at higher pressures, which means the bolt carrier moves faster, components wear out quicker. Also, the rifle runs hotter and dirtier than a mid-length system if using the same barrel. Later, Crane's testing eventually confirmed that the mid-length gas system cuts the failure rate roughly in half over 30,000 rounds compared to carbine length barrels. But now the problem has to do with money and logistics, because these carbine length rifles were already in mass production. So even if you start making mid-length system, that's a lot of money. The next one on the list was the bolt bounce issue on full auto fire. If you look at a slow motion footage of sustained M4 on full auto, the bolt carrier cycled fast enough that the lighter buffer allowed it to start bouncing back before the next round fully chambered, meaning the action was attempting to complete a firing cycle with the bolt fractionally out of battery. So it doesn't mean the bullet isn't seated, it just means the bolt momentarily rebounds after it closes, which leads to potential light primer strikes or misfires. It wasn't catastrophic, but it degraded full auto reliability in exactly the role the M4A1 was issued for. So this issue had been sitting there unaddressed for about 12 years, until they were looking into the buffer design. Like I said earlier, you change one part of the gun, now the entire gun needs to be adjusted, and that's exactly what happened. So the fix for bolt bounce was installing an H2 buffer. The H2 carries slightly more mass, and that weight slows the bolt carrier's rearward travel just enough to keep the bolt fully seated during full auto cycling. The good news were that armorers have replaced these carbines buffers, and units got their guns back with one fewer failure without most soldiers even noticing the change. So at this point, the M4 has better extraction, and now the buffer made full auto much more reliable than it had been at any point since '95. But that's not over yet. The next big deal was that the M4 can't handle dust. This was during a time where new M4 replacement programs were running wild. We got the 416, SCAR, and a bunch of other prototypes being tested, and the M4 finished last on the dust test. 863 stoppages and 19 major failures across 6,000 rounds, with every competitor handled the same conditions better. The honest finding was that the direct impingement gas system tolerates contamination less well than piston-driven designs when lubrication breaks down under sustained fire, and that soldiers were maintaining their M4s better than Army training doctrine actually required. The next on the list was the burst cam. It pretty much made full auto trigger behavior unpredictable. The 3-round burst mechanism in the standard M4 was a mechanical problem. For instance, the cam doesn't reset between trigger pulls, so if a 2-round burst fires and the trigger releases, and if you pay attention to the next pull right here, it only produces 1 round before requiring a full cycle. The breakpoint changed depending on where the cam sat in its travel after the last shot. This just meant that soldiers couldn't develop a consistent feel for the weapon on automatic. So the burst mechanism didn't reduce ammo consumption in any meaningful way. It just made the trigger behavior unpredictable and inconsistent. Let's be honest, anyone would be annoyed by that. So later, when the Army in 2010 made the announcement for the M4A1 upgrades, which was almost 5 years later in Afghanistan, these soldiers were still carrying the old guns, and some Special Forces guys were installing their own ambidextrous selectors from spare parts because the Army never issued them a rifle that already had one. Basically, nothing meaningful was done. Fast forward to 2012. Among all the issues the M4 was having, the M855A1 was introduced to basically address the weak terminal ballistics of the original M855 out of shorter barrels and in longer range fights. So the A1 was designed to provide more reliable terminal performance and better penetration through barriers like glass and light cover. However, the trade-off was higher pressure and accelerated wear on barrels and bolt components at rates that shortened their service life noticeably. Long story short, M855A1 stacked two separate high-pressure variables on the same components simultaneously. The problem kind of went back to where it started, which was the gap between what the platform was originally designed to handle and what the current ammo was demanding of it kept growing. At this time, it's just better off to build a brand new rifle instead of doing non-stop surgery on the M4. When it comes to optics, close quarters optic was too dim. This wasn't really a rifle issue, but red dot technology at this time was obviously not as good as today. The conventional Army was actually ahead because they had adopted the M68 aim point around 97. And SOCOM didn't get the M68 until around 02. Fast forward to 2013, trigger technology was definitely better, but they had to find a way to get them into Spec Ops guns because their stock triggers were so poor, operators bought their own. SOCOM operators were running commercial aftermarket triggers on personal weapons for years before the issued trigger group got fixed. Later, Crane adopted the Geisley Super Select fire trigger for SOCOM in 2013, and it gave operators a cleaner, lighter, more consistent pull than the original. Think about it. These arrived to the unit 18 years after the M4A1 first shipped to Special Operations. If someone was to just widely acknowledge performance gap early, the solution couldn't be implemented a lot faster. So by now, the M4 has gone through so many changes, and that's just the M4, not including what they did with other variants. At the same time, there were multiple submissions to replace the M4, and mainly the goal was to build a gun around the ammo, and they tweak it until it's perfect. That means every moving goalpost shifts everything else until the URGI program. This program was the first formal hardware acknowledgement that the carbine length gas system needed to change. It kept the 14.5-inch barrel, but switched to mid-length gas, directly addressing the overgassing problem that had been documented and understood since the beginning of the platform's life. And the data supporting the switch had existed for years, but SOCOM got it 24 years after the M4A1 first deployed, and 7 years after M855A1 started compounding the wear problem. And the majority of the conventional Army is still waiting for the upgrade. And if you want to learn why replacing the M4 is so painfully difficult, watch this one next.